This is your last practice test for the Pythagorean relation chapter. There are 15 questions. Your test is tomorrow, Wednesday. Wednesday, uh, fourth period. Okay, so the first question says the number 60 has 4 prime factors. So the first thing you want to do is you want to prime factorize 60 to break it down into the product of prime numbers. So 2 is a prime factor. 2 times 30 is one way to represent the number 60. But since 30 is not a prime number, it can be broken down into 2 times 15. So 2 times 2 times 15 is also another way to say 60. And 15 can really be broken down into 3 times 5, which are prime numbers. So 60 can be represented by 2 times 3 and times 5. So there are 4 prime factors. And what we can learn by that is the fact that 60 is not a perfect square, because there is no way we can reorganize those prime factors to create 2 equal numbers, which means 60 is not a perfect square, and there are 4 prime factors. So the answer is true. It has 4 prime factors. The second question says, if a square has a perimeter of 40 meters, so if I draw the square and put little lines in here, if its perimeter is 40 meters, that would mean that each of these sides was 10 meters. And if each of those sides was 10 meters, then 10 squared would be the area, which means the area of that particular square would have to be 100 meters squared, which means the answer is true. If the perimeter of a square is 40 meters, then its area must have been 100 meters squared. Question 3 is 196 is a perfect square. The object of this question is for prime factorization. So 2 and 98 would be the first one, prime factor, non-prime factor. 2 times 49, and then this would be broken down into 7 and 7, which means if I reorganize them, I can make 2 equal groups of prime factors, and therefore we know that 14 times 14 is 196, which means true, 196 is a perfect square. Question 4 says a triangle with sides of 4, 5, and 9 is a right triangle. Well, if I was to draw 4, 5, and 9, it doesn't necessarily mean it's a right triangle. So if I was to assume what he was saying is 4, 5, and 9, 9 being the hypotenuse, it is impossible for the area of the two squares attached to here being 16 and 25, or 25 and 16, that would equal 41, but the area of the square attached to the hypotenuse would have to be 49, which means false. It is impossible to have a right triangle with legs of 4 and 5 and a hypotenuse, which is the longest side, being 9. It is impossible, so the answer is false. It can't be right. Question 5 says a triangle has 3 squares attached to the sides. 2 of the squares have areas of 24 and 25 meters squared. The third side's length could be 7. Is that true or false? Well, what I'm going to do here is actually copy this. I'll copy it, and I'll paste it. And I'll bring it over here. So if the sides are those, there's one possibility is this is 24 meters squared, and this is 25 meters squared. 25 meters squared. Another possibility is this is 25 meters squared, and this is 24 meters squared. Those are the only 2 possibilities for areas of squares attached to the right triangle. If this was the case, since this is a leg and this is a leg, this would have to be 1 meter squared, and none of those side lengths would be 7. But in this case, if one of them is 24 and one of them is 25, the area of the square attached to the hypotenuse would have to be 49 meters squared, and if that was the case, the hypotenuse's length would be 7 meters. So it is possible for one of the side lengths in that situation to be 7 meters. So therefore the answer is true. It is possible to have a side length of the triangle 7 meters. In question 6, multiple choice, what is the whole number whose square root is between 9 and 10? So the square root of 9.5 is going to be like, since I know this is the square root of 9, which is 3, and the square root of 16, which is 4. The square root of 9.5 would be 3 decimal something. So therefore, it's not a square root between 9 decimal something. This is going to be the square root of 81, which is not 9, and the square root of 100, which is 10. So it's going to have a square root somewhere in between there, which means that B is your answer. B, the square root of 90, will be 9 decimal something. Check with a calculator. Square root of 90 is 9 decimal 5 approximately. So its square root is between 9 and 10. Question 7, what's a good estimation for this? Since this is 5 and this is 6, a good estimation for x would be 5.5, which is B, right? B. Question 8, what's the area of the third square? Leg, so therefore the area of this square plus the area of this square equals the area of this square. So a good estimation would be, the actual area of that square would be 7 meters squared. Question 9, what's the approximate value of x? That's a little bit different. So here we have, again, the same setup. This is 7 meters squared, because we just did that question. And the side length would actually be the square root of 7 is the side length. So it says, what's the approximate value of that, round to 1/10 of a meter? So if I take my calculator and put the square root of 7, it tells me it's 2.6. So the approximate value is 2.6 meters. Question 10, what's the value of x? So this time we have a leg and a leg. So the area of this plus the area of this will equal the area of this, meaning this is 144 meters squared. And since that's the area of the square attached to the hypotenuse, the side length would be the square root of that, or 12 meters. So your answer for that one is 12 meters. Question 11, using prime factorization, prove that 100 is a perfect square. So take my 100, break it down into, I'm going to go 4 and 25. Neither one of those is prime. 2 and 2 are prime. 5 and 5 is prime. So 2 times 5 times 2 times 5 would mean that 10 times 10 is 100, and therefore it has 4 prime factors, and the square root is 10. Question 12, what is the approximate square root of 80? Square root of 81 is 9. Square root of 64 is 8. Therefore, the approximate square root of 80 would be approximately 8.9 or 8.8 something. If I put it in a calculator, square root of 80 is 8.94. 8.9 is a good estimation. Question 13, if a square has an area of 36 meters squared, what is its perimeter? Well, if its area is 36 meters squared, that means its side length is 6, and therefore its perimeter, meaning the distance around the whole thing, would be 4 times 6. The perimeter would be 24 meters. Question 14 says a rectangle has sides of 9 meters and 5 meters. What is the length of its diagonal? Well, that simply means it's the hypotenuse of a right triangle. So if I get rid of all that and put 9 meters here, it's really just this question. A squared plus B squared equals C squared. So in this question, I really know my two legs, so I know that 9 squared plus 5 squared equals C squared, or 81 plus 25 equals C squared, or 106 equals C squared. So the actual answer of the diagonal is the square root of 106, which is approximately 10.1 or 2, probably 10.2 or 3, 10.3, and that's your answer for the length of the diagonal. And the last question, it says, what is the approximate sum of the perimeter and the area of this triangle? So the first thing we have to do is take this triangle right here and think of it as just a separate question. This is 3, this is the square root of 45, and this is x. If I attach squares to each of those sides, Ethan, I would have a square there, and a square here. The area of this square would be 9. The area of this square would be 45, which means the area of the missing square, since it's a leg, is 36, because 36 plus 9 would give me the square's area of the hypotenuse. Since the area of that square is 36, that must mean that x is 6 meters. So now I can erase all of this stuff and put 6 centimeters right here. This is a 3, this is a 4, and this is an unknown. And that's called the Pythagorean triple. When the legs are 3 and 4, the hypotenuse will be 5. This is 9, this is 16, this is 25, which means that's 5. So therefore, first things first, the area equals base times height divided by 2. So the area would be, the base of this whole thing is 10. The height is 3 divided by 2. Would be 30 divided by 2, which is an area of 15 centimeters squared. The perimeter would be 10 plus 5, which is 15, plus the approximate square root of 45. Since the square root of 49 is 7, the square root of 45 would probably be 6 decimal 8. We'll say 6 decimal 8, who cares? So 10 plus 5 is 15, plus 6 decimal 8 is 21.8 centimeters as a perimeter, the distance around the outside of the triangle. So the area is 15, and the perimeter is 21.8.